All right, so we're talking Chapter 2, Section 6, second part of the lesson, solving nonlinear inequalities, but now we're taking it up a notch. Before we were only solving like quadratic inequalities or cubic inequalities. Now we're going to take it up a notch and we're going to solve rational inequalities. Now rational is a fancy word for fraction, which means we're going to be dealing with functions that have a numerator and a denominator, each of which is a polynomial. This really is not going to be a big deal. We already have all of the skills from this year. None of it is stuff we need to remember. We've done all of the stuff that we need already. We just have to put it all together. Okay? So, two things we need to remember. Number one, when we have a function in the form f of x equals g of x over h of x, right here, anytime that the numerator is equal to 0, the graph has a 0. It crosses the axis. Okay? Anytime that the denominator is equal to 0, that's a whole or an asymptote, which we've already talked about this year. Those are undefined values in the domain. If they share a 0, if the top and bottom have the same 0, that is a whole. If it's only a 0 of the denominator, that's an asymptote. Okay? So that's going to be the big change. We're still going to do sign charts. The big change will be that instead of just the zeros on our sign chart, we will have the zeros and the undefined values to deal with. Okay? Other than that, it's the same thing we've been doing. We find the zeros of polynomials, which we've been doing for weeks. Should not be any big deal. Okay, so when we are solving a rational inequality, we've got some added steps to what we had before. Okay? We are still going to make sure that the inequality has a 0 on one side. That's going to be important. So everything has to be on one side. It has to be less than 0 or greater than 0. Then we need to make sure that it is in the form f of x equals g of x over h of x, which means it's one fraction. Okay? We don't want to have like a fraction plus a whole number. We want to have one fraction. Then we need to figure out what the zeros are of the numerator g of x and the denominator h of x. So that's step 3. We're going to indicate those values on our sign chart. Then we are going to figure out the big thing about h of x. We don't necessarily need to check values around those. We just need to make sure they don't get included in the domain because those values are not in the domain. We're going to test values in each interval to see whether or not those values are positive or negative. That's all we really care about. It's a sign chart. And then finally, we would take our sign chart and write down the answer. Where is it positive? Where is it negative in interval notation? Okay? We've done all of the skills required to do this already. We just have to put it all together. Okay, everything here is something we've done this year in this course. There's no new material here. It's just us putting a whole bunch of other stuff together. So here we have our first two examples. We're going to go through these. Number 1 and number 2 both already have step 1 taken care of. There is a 0 on one side. They already have number 2's taken care of. They're already a fraction, g of x over h of x. So we need to start off by figuring out the zeros of the numerator and the denominator. So we start off with, when is x minus 2 equal to 0? When x equals 2. Okay? When is x squared plus 3x minus 18 equal to 0? How do we solve that? We factor it. Numbers that multiply to negative 18 and add to positive 3 would be 6 and negative 3, which means that our x values for the roots of that function are negative 6 and positive 3. Now, the zeros of the denominator, that would be these two, are excluded values from the domain. If we have these values plugged in and we have division by 0, that's a problem. Okay? This one is a 0 of the graph. Any 0 for the numerator is the 0 for the graph. Okay? Once we have these values, 2, -6, +3, we take these to our sign chart. So let's see here. -6. Now, hold on. -6 and +3 are the excluded values. That's why I put them in red. And then 2 is the 0 of our graph. So, these three values break the number line up into 4 intervals. We need to test a value from each interval. Doesn't matter what value. Any number we want, we can plug in. Okay? So, we need a number that is smaller than -6. I like to use like tens, so -10 would probably be a good one to use. Okay? And again, we're only looking to see whether it's positive or negative. So when we plug -10 into the numerator, right here, we have -10 minus 2, which is -12. On the bottom, when we plug in -10 and we square it, that's 100. Minus 30 minus 18, which is a positive number. We don't care what positive number, but it's positive. So this fraction overall has a negative on top and a positive on the bottom. When we divide a negative by a positive, the result is negative. So everything to the left of -6 is going to be negative. Doesn't matter the values. What matters is it is negative. Okay? Then we go between -6 and +2 and we pick a value. 0 is a good one. When we plug in 0 to the top, we have -2. When we plug 0 into the bottom, we have -18. -2 divided by -18 is positive. So the entire section between -6 and +2 is positive. And that's all we care about, is whether it's positive or negative. We don't care about these specific values. Then we pick this is the one that sucks. We have to pick a value between 2 and 3. So 2.5 or 5/2 is probably our best option. Now plugging 5/2 in here is not going to be fun without a calculator. Okay? So we plug in 2.5 to the top. That's positive, because that'd be 1/2, right? Positive 1/2. When we plug 2.5 into the bottom, 2.5 squared would be 25 over 4, or 6.25. And then 3 times 5/2 would be 15/2. So that's like 7.5. So we're talking 13.75 minus 18 is negative. That's what we're looking for. It's negative. So we have a positive divided by a negative. That section in between 2 and 3 is negative. Finally, we need one number greater than 3. Doesn't matter what we pick. 5 works. Plug in 5. 5 minus 2 on top would be positive. 5 squared plus 3 times 5 minus 18 is positive. So we have a positive divided by a positive, which is positive. Okay, so once we complete the sign chart, which is a bulk of the thinking, then we need to ask ourselves, where is this function greater than or equal to 0? Okay, so between -6 and +2, and it includes 2 because 2 is a 0. Why doesn't it include -6? It's not in the domain, period. Okay? And from 3 to +infinity. So those sections of graph would be our solutions. So we would say the answer to this would be from -6, which is not included, so it gets a rounded bracket, to positive 2, which is included because it's a 0, so it gets a square bracket, and from 3, which is not in the domain, so it is not included, to positive infinity. That would be the solution to this nonlinear inequality. Okay, on to the second one. So, I'll move this over here over the top of this and get it out of the way. All right, so on the second one, same deal. We've already got it equal to or less than 0, so we don't need to worry about that part. It is already one fraction, so we don't need to worry about that part. We need to ask ourselves, what are the zeros of x squared minus 4? Yep, that would factor into x plus 2 and x minus 2, which means its roots are negative 2 and positive 2. These are the zeros of our graph. Okay? Then we look at the denominator, because that's not allowed to equal 0, so we ask ourselves, when is x squared minus 10x plus 25 equal to 0? Yeah, that factors into x minus 5 times x minus 5, or x minus 5 quantity squared, which means that we have a non-included value of x equals 5 with a multiplicity of 2. Okay? So this value is the value that is excluded from domain. All right. So we go to make our sign chart. Get all this stuff separated out here. We need those three values on our sign chart. We've got negative 2, which is a 0. We've got positive 2, which is a 0. And we have positive 5, which is an excluded value. Now we start testing values to see whether or not they're positive or negative. That's all we care about. We don't care about values, we care about the sign, positive or negative. So we pick a value that is smaller than negative 2, doesn't matter what value. Negative 5, okay. We plug it in. Negative 5 squared would be 25, minus 4 would be positive 21. So the top's positive. Negative 5 squared is 25. Plus 50 plus 75 plus 25, that's positive as well, right? That's positive 100. So when we plug negative 5 in, we have a positive on top, a positive on the bottom. Positive divided by a positive is a positive. Then we pick a value from between negative 2 and positive 2. The obvious choice is 0. We plug 0 into the top. 0 minus 4 is negative 4. On the bottom, 0 minus 0 plus 25 is positive. A negative divided by a positive would be negative everywhere between those two. Then we pick a value between 2 and 5. 3 seems like a healthy choice. 3 squared minus 4 would be positive 5. So we have a positive number on top. On the bottom, we have 3 squared, which is 9, minus 30 plus 25, which is positive. So we have a positive on top, positive on the bottom. That entire section is positive. Now I know what you're thinking. Gee, it seems like it always switches. It doesn't always switch. Okay, that's why we got to check them all. For instance, if we pick a value that is bigger than 5, like 10, and we plug it in, 10 squared minus 4 is clearly a positive number. 10 squared minus 10 times 10 plus 25 is a positive number. Positive divided by a positive is still positive. That's why we have to check. It doesn't always switch. Now, the basis for that is all based on multiplicity. Okay? That non-included value is a multiplicity of 2. That's why it didn't change. But that's a whole other discussion. Okay? We just need to pick a value from each interval and check. Okay? Then we turn our attention to writing our answer. We are looking for any sections of graph that are less than 0, which would be this section here between -2 and 2. However, it is only less than, not less than or equal to, which means rounded brackets all around. So our answer would be -2 to +2. Okay, on example 3, this one is a little bit easier in a way because even though it is a rational function, the top is constant. Okay? The top is constant. So there are no zeros for the numerator. We have one excluded value, one value that is not allowed to be. That's when the denominator is equal to 0. When is x minus 3 equal to 0? So we have x equals 3 is excluded from the domain. That's the only value we have to worry about. That is the only value on our sign chart, is 3. Okay, so we go to do our sign chart, and the only value on it is our excluded value of 3. Other than that, we just need to consider one number greater than 3 and one number less than 3, and we need to think about signs. So let's say we did 0. 0 is good. 0 is less than 3. 2 is still on top. No matter what we plug in, we have a positive number on top. In the bottom, we plug 0 in. 0 minus 3 is -3. So we have a positive divided by a negative, which means that everything less than 3 is negative. Then we pick a number bigger than 3. Doesn't matter what number. 5 is a good number. So 2 over 5 minus 3 would be 2 over 2, which is a positive number. So everything on the other side of 3 here is positive. Then all we have to do is figure out where we are greater than 0. That would be from 3 to positive infinity. 3 is not included ever in this case because it's an excluded from the domain value, and it's also just greater than. So we wouldn't have to worry about it being square versus round because if there's no or equal to, it's a round bracket every time. Okay, so 3 is relatively easy, and as easy as 3 was, 4 is not. Okay, because 4 is the first example we've had that is not one fraction. So the first thing that we have to do is turn it into one fraction. So right now we have 4 over x plus 5 plus 1 over 1. To add two fractions together, we have to have a common denominator. That common denominator is x plus 5. So the bottom and the top of this fraction get multiplied by x plus 5, which makes this 4 over x plus 5 plus x plus 5 over x plus 5. It's still less than or equal to 0. That part has not changed. Which means when we add those fractions together, we're really only adding the numerators. So we do 4 plus x plus 5, which would be x plus 9. Very good. Over x plus 5. Now it is in the correct format for us to actually do the problem. I don't know that our Algebra 2 classes got to adding and subtracting rationals last year. Mine did, but I can't guarantee that the others did. Okay, and we did it right before e-learning, so God knows how effective we were. Okay, End result is we now have a numerator and a denominator just like the other problems. So then we go and we ask ourselves, when is the numerator, x plus 9, equal to 0? -9. So we have a 0 for this function at x equals -9. When is the denominator equal to 0? -5. That is an excluded value from the domain. Okay, so when we go to do our sign chart, we need to include -5 and -9 on our sign chart. Make sure you get those again in order so that they're placed in the correct order from least to biggest on your number line. Now we go in and we put in values to the function to see whether it's positive or negative. Same thing we've been doing. So say we use -10. When I plug -10 into the top, -10 plus 9 is a negative number. Yes? When I plug -10 into the bottom, -10 plus 5 is a negative number. So a negative divided by a negative, everything to the left of -9 is a positive number. Then we need to pick a number between. So we just need to pick any number between -9 and -5. -6 will work fine. -6 plus 9 is a positive number. -6 plus 5 is a negative number. A positive divided by a negative is a negative. And finally, we need to pick one number that is greater than -5. Anytime we can pick 0, I highly suggest that we pick 0. So if we plug in 0, we have 9/5, which is a positive number. So this entire section would be positive. We are asked, when is our graph less than or equal to 0? That would be from -9, and -9 would be included because it's a 0, all the way over to +5, which is not included because that is an excluded value. So we never include those. Okay? So our answer would be this graph, or this rational, is less than or equal to 0 from -9 to -5, including -9. Okay, so example 5, we're going to do 5 and 6, and then I'll stop this video and I'll do another one later for 7 and 8. So, let's see here. First things first, it is not equal to 0 or less than 0, so we need to move that 4 by subtracting 4 from each side. Now, unfortunately for us, that 4 is not part of the fraction that is already there. That gives us 3 over x minus 2 minus 4, which I'm going to write as 4 over 1. Then we need a common denominator so that we can add those together. That common denominator would be x minus 2. So we multiply the bottom and the top of this fraction by x minus 2. That would give us 3 over x minus 2 minus 4x minus 8 over x minus 2. Still less than 0. Now, be careful when you do this because subtraction, you got to watch your signs. This would turn into, when we combine these, remember we're just subtracting 3 minus 4x minus 8. So that would be negative 4x plus 11 over x minus 2. Now that it is one fraction, we need our zeros and we need our excluded values. So our 0 is actually not a nice number at all. Negative 4x plus 11 equals 0 would render a 0 of 11/4. Okay, so we have a 0 of 11/4. If you're worried about where that is on a number line, it's always helpful to turn it into a decimal. 11/4 is 2.75. Okay? So we have a 0 at 11/4. The excluded value is a lot easier. What value is excluded? 2. Okay? X minus 2 cannot equal 0, which means x equals 2 is excluded. So now we're good. We're ready for the sign chart. On that sign chart, we need our 0 and our excluded value. So we have our 0. Actually, let's put the excluded value. It's lower. So the excluded value is 2. And then we have our 0 of 11/4, or you could write 2.75. That would be fine. You just need to be careful with decimals because they really do make this stuff harder if they're ugly. This is a nice decimal, so we can get away with it. Now we just need to go in and test. Now the downside is, what numbers are between 2 and 11/4? All decimals. Okay, we're going to have to do like 2.5 or 5/2. Okay, we plug these in to our adjusted equation right here. Again, if we can plug in 0, which is to the left of both of our numbers, we should do that. When we plug in 0, we have 11 over -2, which means everything below 2 is negative. When I plug in 2.5 or 5/2, I have 4 times 5/2, -4 times 5/2, which is -10, plus 11 is positive 1. On the bottom, I have 2.5 minus 2, which is 0.5. So it's positive as well. So the top is positive, the bottom is positive. That makes the entire fraction positive. Then we need one number to the right. 3 would work okay. Plug in 3, we have -12 plus 11, which is negative. And on the bottom, we have 3 minus 2, which is positive. Negative divided by a positive is a negative. So, now that the sign chart is complete, we look for where is that less than 0. Yep, that'd be from -infinity to 2, and from 11/4 to infinity. So we just write that out in interval notation, -infinity to 2, and 11/4 to infinity. We don't need to worry about square brackets versus round brackets because it's just less than, not less than or equal to. Final example we're going to get in today is example 6. It has a very similar problem. It is not equal to 0, so we need to start by moving that x, which gives us 0 is greater than or equal to 20 over x plus 1 minus x over 1. Common denominator is x plus 1. So that would give us 0 is less than or equal to 20 over x plus 1 minus x squared plus x over x plus 1. Just distributing that x. When I combine those two fractions, I'm only combining the numerators. I'm also going to write it in descending order. That would be negative x squared minus x plus 20 over x plus 1. Again, we need to figure out what the zeros are of the numerator and the denominator. Your numerator zeros are your zeros. Your denominator zeros are your excluded values. Now you look at that top number and you say to yourself, gosh, I don't think I can factor that. right? Because it's the negative. The negative's an easy fix. Factor out -1. That just changes all of the signs. That is easily factorable into +5 and -4. Which means our zeros are -5 and +4. Our excluded value is a lot easier. That means x plus 1 equals 0, which is what value? -1. Okay, x equals -1 is our excluded value. So on our sign chart, we have to look at those three values. We have our excluded value of -1 and our zeros of -5 and +4. And we go in and we pick values, we plug them in, we find whether it's positive or negative. Same thing we've been doing. Okay? So for instance, a number smaller than -5, oh, I don't know, how about -10? -10 squared would be -100. +10 plus 20 is still negative. Doesn't matter what it is, it's negative. Okay? On the bottom, -10 plus 1 is still negative. So we have a negative divided by a negative. Everything below -5 would be positive. Between -5 and -1, let's try -2. Plug in -2 here, we get -4, because it's -2 squared. So that'd be -4. +2 is -2. +20 is a big positive number. Okay? So the top is positive, and the bottom, -2 plus 1 is negative. A positive divided by a negative is a negative. So everything between -5 and -1 is negative. -1 to +4, we're going to plug in 0. That would be 20 over 1, which is positive. So everything in this section here is positive. And then something above 4, 5 is fine. That'd be -25 minus 5 plus 20, which is negative, over 5 plus 1, which is positive. Negative divided by positive is negative. Final step then is to grab the solution set. Remember that we're looking for less than or equal to 0 because the 0 is on the other side, right? So we're looking for negative or including. So that'd be here and here. So our answer would be from -5 to -1 with a square bracket for -5, and from 4, which should be a square bracket, to infinity. We're out of time in class, so that's the end of this video. I'll do another video later for 7 and 8 and post it later.